Part B, let's solve 5 times the absolute value of q minus 2 is equal to 9. Now there's an additional step here. In order to use that technique above where you set the guy inside the absolute value equal to the guy on the right side or the opposite of the guy on the right side, you've got to have the absolute value isolated. You have to have it by itself on one side. Okay, so how do I solve? Think of the absolute value of q as just the unknown. How do I solve for the absolute value of q? What do I do? Add 2. Well, what does that get me? 5 times the absolute value of q equals 11? Yeah? Then what do? Divide by 5. So I get the absolute value of q is equal to 11/5. So then what can you say about q? Either the absolute value of q equals 11/5 or negative 11/5. I like to put the smaller number on the left. Or q equals, either q equals negative 11/5 or q equals 11/5. There you go. In this part C, same direction solve, we have the absolute value of 3a minus 1 equals the absolute value of 2a plus 4. So you might think, oh man, we're going to have like 4 answers or something. But you don't. You don't, because there's only a couple of things that can happen here. Okay, so your goal is to get rid of the absolute value so you can solve for a. Just like when you have a bunch of parentheses in an equation, your goal is to multiply out the parentheses usually so you can solve for the unknown. So isn't it possible, I'm going to put this on the right side, but it's the easier one to comprehend, so I'm going to write it down first. Isn't it possible that the guys inside the absolute values are equal? Isn't it possible, in other words, that 3a minus 1 is just equal to 2a plus 4? Sure. Why not? But then what's the other possibility? And there really is only one other possibility. Well, we're trying to get rid of absolute values. So what's another way these two quantities inside the absolute values could relate to each other? I'll give you a hint. Isn't it true that the absolute value of negative 5 is equal to the absolute value of 5? How are negative 5 and 5 related? What do we call those kinds of numbers? Negative 5 and 5 are opposites, right? They're opposites of each other. So isn't it possible, so this is the only other possibility, isn't it possible that 3a minus 1 and 2a plus 4 are opposites of each other? So that's the other equation that you write down. So 3a minus 1, you could write down 3a minus 1 is the opposite of the quantity 2a plus 4. So these are the two equations. Now, some of you are thinking, well, there's a third equation, right? Couldn't you say the opposite of 3a minus 1 is equal to just 2a plus 4? It is redundant because that's the same thing as, that'll get you the same solutions as this. Because you could just multiply both sides by a negative and then you'd get that. So yeah, we don't need that. We don't need that third equation. There's still only two possibilities. So it's really the same technique. You set the guys inside the absolute values equal or the guys inside the absolute values opposite, and you solve those two equations. Okay, so just to keep your mind active, I'm going to have you guys, let's have this half of the room solve the right equation since it's closer to you. Let's have this half of the room solve the right equation. Let's have you guys solve the left equation, and then we'll compare our answers. For you guys solving the left equation, don't forget to distribute the negative first, right? Okay, what are you guys getting over there? Left side. Negative 3/5 is what I got, I think. Yep. So a equals negative 3/5. And what are you guys getting for the second equation? A equals 5. Do you guys need to see this, or are you good with that? Okay, so yeah, those are both right. Those are both right. Okay, any questions on solving absolute value equations? It's not really what we're here to talk about today, but you kind of need those techniques for solving absolute value inequalities.